Okay, so in this video, I would like to prove that a function is uniformly continuous. Specifically, I want to prove that the function natural log of x is uniformly continuous on the open interval from 1 to 2. And this is not maybe a super easy result to prove just directly using the definition of uniform continuity. So we're going to start by stating a theorem, which is a very important theorem involving uniform continuity. And that's that if you have a function f that's continuous on some closed and bounded interval from a to b, then it's always the case that f is uniformly continuous on that same interval. So, pick your favorite continuous function. So it could be x squared, it could be sine of x, whatever. And, on a closed and bounded interval, that function is automatically going to be uniformly continuous just by the fact that it's continuous as well. So, we're going to use that here because we know that natural log of x is continuous on its whole domain. So if we extend this interval to the closed and bounded interval from 1 to 2, then we know that natural log of x is still defined on this interval. Like there would be a problem if we were dealing with an interval like interval from 0 to 1 because natural log isn't defined at 0. But this interval is totally fine. We know that natural log of x is defined here, and we know that it's continuous. So we know in particular that natural log of x is uniformly continuous on this interval here, which is the closed and bounded interval from 1 to 2. And so then if we restrict back down to the open interval from 1 to 2, it'll definitely be the case that natural log of x is still uniformly continuous on that interval as well. And that is basically the proof. So you can use this if you're given any function that you know is continuous and you just want to prove that it's uniformly continuous on an open interval like this, as long as you can extend that open interval to a closed and bounded interval and the function is still defined there, then this same method will work. And yeah, that's it.